so we did R cross P, right? The right hand rule says that R cross P goes out. So if you want to find out, this will tell you the direction. This will tell you the length of the vector, right? If you do A times B times the sine of alpha. So if you take the lengths of both vectors, you multiply them together, and you multiply by the angle between them, that tells you how long your last vector is. Okay?
What do you mean last vector?
The answer. So if you want to take the cross product, let me just erase this and let's just talk about the cross product, because then you can figure it out. So you want to take the cross product between two vectors. Let's call this A. Let's call this B. Okay? So the magnitude of A cross B, that's the length of A cross B. Is that okay if I write it that way?
Yeah.
So if you take A and cross it with B, you'll get a vector that sticks out this way.
What's the absolute value for?
That's telling you it's the magnitude of A cross B.
Okay.
This won't tell you the actual vector, this will just tell you how long it is. Okay? The way you find the magnitude of it
The angle.
is by taking the length of A.
Wait, magnitude is angle or?
It's the length.
Okay.
Okay? So you take the length of A, you multiply it by the length of B, and then you multiply by the sine of the angle in between them. Let's call it alpha. Okay? So when you take these vectors and you do the cross product, the length of the vector that comes out of them will be this length. It'll be the length of A times the length of B times the sine of alpha.
And it'll be directly perpendicular to both of those.
Yep. Perpendicular to both. Now, it could be perpendicular sticking out of the page, or it could be perpendicular going into the page, right? So that determines if it's coming out, it's positive. If it's going in, it's negative. Okay? So the way we figure that out is you take your first vector and you put your fingers on it, and then you curl your fingers towards the second vector. That make sense? This is called the right hand rule. It only works with your right hand. Your left hand will get it wrong. But if you take your right hand, you put it on the vector, the first vector.
Yeah, this didn't make sense to me.
What was that?
Yeah, I said this didn't make sense reading it.
Yeah. So this is what it's talking about. So you have two vectors, right? A cross B. So A, you're trying to evaluate A cross B. A, whichever direction it's pointing, you put your right hand on, the fingers of your right hand, and you curl your fingers towards B. Does that make sense? Whichever way your thumb's pointing is the direction the vector will go.
Okay.
So which direction will A cross B go?
Negative.
Yeah, that'd be negative. What about B cross A?
Positive.
Yeah, because you'll start here, curl your fingers like that, you go out this way. How about, let's call this C, this D. What if you did C cross D?
Positive.
Yeah, you put it here, curl it that way. D cross C? It's just negative.
How
It's
would
the
you
opposite.
put your hand though?
You put it this way.
Okay.
Then like, you could even have E, F. What would E cross F be?
positive.
Yep. All right. You can always tell the kids that are in the testing center taking either vector tests or physics tests or like statics and dynamics tests because they're always doing this. Trying to figure out which direction to point. So that's this picture. This one is a little bit different. It's just showing you, so if you put your thumb on C, your pointer finger on D, and have your finger stick in, that's the direction that Z will go. So you put your thumb on the first one. So if I put my thumb on A, my pointer finger on B, then my other finger will stick into the page. So that one some people use too. The curling one is the most simple. It's easiest to remember. But you can't, because you have to remember that your thumb goes on the first one, your pointer finger goes on the second one. Your third finger shows the direction of the cross. And then the screwdriver example is it's similar. It's if you take a screwdriver, you started it out at B, and then twisted it, or you started out at A and then twisted it towards B, which direction would the screw go? Go into the page, so it's negative. That's just a couple ways of remembering the cross product.
Okay.
So angular momentum. If you have a vector that's 2.5 I, this is your R vector, and your momentum, your linear momentum, is 8J. Which way is your angular momentum vector going to point?
Taking cross product of which one?
So it's angular momentum is R cross P. You never switch the order. It'll always be R cross P.
Positive?
Yeah. So it'll come out of the page, so it'll be positive. So you know in that case, L will be something K, positive. So how long will this vector be?
It would be 20.
Yeah.
20K.
So this would be 20K. What if we change this angle? I'm not going to change it for real, but maybe this is only 70 degrees. Then what would the length of your angle be?
20 sine is 70. Or no, 8 times 2.5.
Yeah,
sine
so that's,
70. That's the same
that is
thing?
20.
It is
20
the same
sine
thing?
is 70.
Okay.
Same thing. Still be positive. Okay. What if you had one where it was, your position was 2J. This is your R vector, and your linear momentum was 3I.
It's going to be negative.
Negative?
And your cross product would be 6K, 6 negative K, or negative 6K.
Yep. That'd be your angular momentum. And then you can do the same things. We're not going to do this example, but if you had let's say you had a momentum that looked like that, and an R that looked like that, which direction would the K or the cross product point?
Positive.
It'd be positive. And the way that you compute this, because this would give you, say this was 5J plus 3I, and this one is just 3I. How would you compute this using just the lengths?
You have to do the matrix.
You could do the matrix, yeah, but you can also still do this. It just takes a couple more steps. You'd have to use, so this triangle is 5 and 3, so you could find the inverse tangent of 5 over 3 and find this angle.
Well, why is the 5? Where'd you get the 5 and the?
That's this angle here, or this vector.
Okay.
So you can find the angle between them using geometry. Then you can find the length of this. It'd be the square root of 5 squared plus 3 squared. Right?
Okay, yeah.
And then you'd be able to do, this L would be equal to square root of 5 squared plus 3 squared times 3 times the sine of alpha, or of theta, right? This is alpha, call it alpha. Be consistent. Okay? So they don't always have to be 90 degrees. You can solve them other directions. Or you'll get the exact same answer. Oh, and this would be K. You get the exact same answer if you do the matrix method.